Assalamualaikum and good evening doctor. I am Shazan. You are from group 9. We would like to present lab C SCR speed control. Introduction. SCR silicon control rectifier only allow current to flow in one direction. Variable power provided to the motor is controlled by the device. Used in devices that require high power control, perhaps at high voltage. Forward blocking, forward conduction and reverse blocking are the three modalities. Objective. To show the operation of an open loop electronic variable speed control for a DC motor. The purpose of this study was to compare the working efficiency of a DC motor with and without a filter, to test the performance of a DC motor in an open loop system for a speed control.
I'm Muhammad Zakir bin Izam and I will explain the methods we use in the experiment. So for this experiment, we will need a DC motor, a DC voltmeter and ammeter, electrodynamometer, hand tachometer, connection leads, timing belt, and the SCR speed controller module. This is the instrument that we use. And this is the circuit diagram showing the connections that we use. In the first activity, we will manipulate the rheostat until we have a reading of 140 volts, and then we will measure the armature current and field current from the ammeters and the motor speed from the tachometer. We tabulated all the results and we repeat for voltage of value 180 volts, 220 volts, 260 volts and 300 volts. After we finish, we turn everything off. In the second activity, we will couple the DC motor with electrodynamometer using the timing belt, and then we manipulate the load knob and the rheostat until we have a reading of 1000 RPM and on the tachometer at 0.7 Newton per meter load. And then we will measure the value for the armature voltage, armature current and field current. And then without altering the rheostat, we turn the load back to 0. And then we will measure the new values for armature voltage, armature current, field current and motor speed. In the third activity, we will include the LC filter of the SCR speed controller, and then we will repeat the first and second activity for the LC filter. After we finish, we turn everything off and we organize our workstation. So in summary, in this experiment, we are investigating the use of SCR speed control on DC motor. In the first activity, we are observing the effect of armature voltage on the armature current, field current, and motor speed. In the second activity, we are observing the change in armature voltage, armature current, field current, and motor speed when going from full load state to no load state. And in the third activity, we repeat the first and second activity with the addition of LC filter on the SCR speed control.
My name is Leong, and now I will talk about the safety precautions conducted during the lab session. First of all, proper attires are worn during the experiment, including covered shoes, long sleeve is folded up, hair is tied up tidily if the person having long hair. Safety operating procedures are also instructed by the lab assistant are obeyed throughout the experiment. Connection to the circuit is done while the input power is confirmed off. This is to ensure no accident happen while handling high voltage DC motor. Input power is also turned off right after de-energizing the DC motor at the end of the experiment. Now I will talk about the result and discussion of the experiment. This is the result of first activity. Notice that the armature current and the field current is almost similar at various DC motor speed, and the DC motor speed is directly proportional to the supply voltage. Thus, speed control is achieved by varying different supply voltage. Here shows the results for second activity. As you can see, measurements are taken at motor speed at 1000 RPM and also 0.7 load. Measurement also taken at no loads condition. For the third activity is with LC filter added to the circuit. Same as activity 2, the measurements are taken as follows. In this experiment, speed control of DC motor is done possible by SCR speed control. SCR, as you can see, the schematic diagram is here. SCR firing angle can be adjusted with variable resistance in the gate terminal. In this experiment, R1 knob is the resistance. Speed control is achieved by adjusting R1 knob. The greater the resistance, the later the SCR will be triggered. DC motor will receive less average power. Here shows the difference between the unfiltered DC power and filtered DC power. Filtered DC power requires smaller voltage needed to achieve higher speed. This is due to the higher average power received by the DC motor. It smoothens the operation.
For conclusions, an open loop electronic variable speed control for a DC motor has been demonstrated. Furthermore, open loop is typical due to no feedback from output speed. The filtered DC power ensures that the DC motor runs smoothly and efficiently. That's all from us. Thank you.